Hello, ET350. This will be lecture 10. What I'm going to do today is go over a SolidWorks introduction and CAD up some parts that are very relevant to your brush DC motor project. And so what we're going to do is we're going to model a rotor, a stator, and maybe some end caps and put it all into an assembly. And hopefully this will be helpful in getting a head start on your projects and even your homework. All right, so let's begin. So what we have here is SolidWorks, okay, and this is what you should see when you first open. Now, if you use Inventor or Fusion 360, no problem, but hopefully the skills that you learn in this video could translate to what you could use in Autodesk Inventor, okay? So what you want to do is first create a new file, and so there's part assembly, and we want to create a few parts first. So let's create a part, and you can see here in the upper part of the screen, you can see this part at the top, right? And so that tells us we're in the 3D world, and the whole idea of SolidWorks, or a big idea, is 2D sketch, 3D cut, or 3D extrude. Okay, so right now we're in the 3D world. And the first thing we want to do is create a cylinder, let's say, for our rotor. So we'll do extrude base. I'll pick any plane, let's say the front plane. And now notice it says I'm in the sketch of the part. So now I'm on the 2D world. And in this sketch, I can now pick a circle. So that's that circle command. And I can click the origin and then create a circle. Notice the color is blue. So I'll accept that check. And notice it's blue, right? And that means I can change the diameter. Now, let's say you had created a circle and you had not been able to select the origin for some reason, okay? And I'm gonna delete this one. So select this one, delete it. What would I do? How would I move it to there? Well, there's a few ways. I could grab it and then just drag it onto there and see how it shows up. That coincident command, or that coincident yellow icon, that tells us it's gonna snap to the origin. Another way is to use your left hand, hold the control key down, click both the origin and the center of the circle, and notice this properties tab on the left comes up, and you can hit coincident, boom, and it snaps it right to center. So multiple ways to move your parts around. Okay, then what we're gonna use is smart dimension here. So smart dimension at the upper left, we can go and click the circle, and we can put in any dimension. And so SolidWorks is nice in that it knows if you put in a dimension like inches or millimeters or centimeters, it knows to scale it appropriately. So we can even mix dimensions. So I can add in 1.5 IN, and I do like to put the dimensions just to make sure no, default dimensions get confused, right? I actually default and put in or not default, I put the inches in this case. So 1.5 inches, boom. Okay, so I have that. Notice this turns black. I accept my dimension. If I go and try to drag on it, it doesn't move. And this is a key thing. You want all your sketches to be fully defined or black, right? If you don't see that it's black, you see it's blue, that means it's kind of arbitrary. It just, so be very careful about that. And so here we go. We're done with the sketch, and we can go and exit the sketch. There's that icon on the top right. And what it'll show us now is a preview of what it'll extrude. So now we're almost to the 3D world, okay? Now I can go in here and type in, let's say 2 inches. So I can put 2 IN, click anywhere on the screen, and it gives us the preview of what it's gonna extrude, okay? And so, okay, I like that. I go check, and excellent, I have this done. Now let's go, oh, I made a mistake. I either made a mistake on the sketch or I made a mistake on the extrude. And if I made a mistake on the extrude, what I can do is go to this design tree on the left and you go right click and go edit feature. If I made a mistake on the sketch, I would go to edit sketch. So let's just go back and edit it just to show you how to do that. So we go edit sketch here. And I can now go back and change my length. So let's say I didn't want 2 inches, I actually wanted 2.25 inches. No problem. Go there, see the updated preview, hit check, excellent. Now let's say I didn't like that 1.5 inch diameter. I could go here, right click, edit sketch, and now I'm back into that 2D world. Let's say I didn't like 1.5, I wanted 1.75, whatever. And so I go inches here. You don't have to do inches. You just need to make sure though, if you're not putting a unit, your default is set to the desired units that you want, okay? All right, so 1.75, fine, check, I'm happy with that. So I have a cylinder now. So this could represent the rotor. And let's say now we want to make a hole for the shaft. So I can go in here and now I can click any surface on the front or back, and I can now go, instead of boss extrude, I want to do extruded cut. So click that, extruded cut. I'm back into the 2D world. Notice it says sketch of part, not part. So I'm on this face, and you can see that red origin is on that face. So I look at that and I go, okay, I want to put a hole. So I'm going to again go to my circle command, go to the center. Notice it snaps orange. So click and drag a circle. And then I'm going to go to smart dimension, and I'm going to add a circle, dimension. So then I click here, okay? And so let's say I have a shaft that's 6 millimeters. So watch this, I can do 6 millimeters. And then I can do plus. I can actually put equations and different units, and it'll know how to scale everything. Solidworks is very nice that way. And the 3D printer, let's say 3D prints holes a little smaller than normal. So if I want to make sure that it can slide in, I might add 8 thousandths. So 0.008 inches. I might add 15 thousandths depending on the slip. So with your 3D printer, you guys can play with those different tolerances, right? The other thing you can do is just drill it undersized and then just drill the hole that you want right through if you have the right drill and a power drill. So, okay, so 6 millimeters plus 0.008 inches, I hit check, and good. That seems about right. Okay, so you always want, when it does that smart dimension, you want to think in your head, did that go to a size that made sense? And sometimes you miss a 0 or a decimal and it doesn't, and so just be cognizant of that. Okay, so we're good. It's about 0.24 inches. Great. Okay. So I accept that. And now we have this situation where it's trying to extrude and it's giving you a preview. Now, sometimes that preview might be like this, and you're like, whoa, that doesn't make sense, right? I don't want it to cut this way. All it is this arrow button here that shows you the direction, okay? Sometimes SolidWorks is smart, sometimes it's not. So you need to make sure that it's cutting in the direction you want. You can actually cut in multiple directions. So if I was on a plane right down the middle, I could cut in both directions, but since we're on the end, we don't need that direction too. Okay, so I can either make a blind hole of, let's say, 1 inch, where I don't go all the way. And let's just see what happens. I go check, accept that. And sure enough, if I rotate, and by the way, to rotate, I use the middle mouse, the wheel, and I click down and I move it around. If I want to zoom in and out, I can scroll the middle mouse wheel. Okay, so I go here. If I, so what I do to kind of move in and out, I zoom out, center over where I want to zoom in. Okay, that's kind of my trick for panning, I guess. But you can pan as well. So if I rotate, I can see, yep, I made a blind hole of 1 inch. And again, if I don't like that, I can always go back to the design tree, right click and hit edit feature. So if I go here, hit edit feature, instead of a blind hole, I could do a through all. Boom. So through all, it'll show me the preview, hit check, and yep, that hole is going all the way through. Just to show you some fanciness, this is kind of neat. I can go right click, edit feature, and I could do even an offset. Look at all these options. Offset from surface, right? So I can go in here and say, let's say offset from surface. It's going to ask you the question in this pink box, what surface? Well, let's say the back surface. And so I could make it, I don't know, maybe I want it always 0.25 inches off the back surface. And you can see it's previewing a 1/4 inch. So that might be nice, because now even if I change the length of this of the cylinder, the hole will always go to 0.25 inches off the back, right? And we can even measure that. Watch this. I go to the evaluate tab and I go to this measure tool. And now what I can do is I can click the inner surface on one side and I can click this outer surface on the other, and notice what it tells me. The distance between those two surfaces is 1/4 inch. Excellent. Okay. Now let's say I go and don't like I go, crap, I made a mistake on the first part here. So right click, edit feature, and I need it to be maybe a little bit longer, like let's say 3 inches. Okay. Check here. But notice, because I had that offset of a 1/4 inch, it's still there. And look, I can hit this and I can see the preview. You can see the edge here is still a 1/4 inch away. You can see all the way down. And we again can check the measure tool. And then we can go here, click the inside, click the outside here, and bang, 1/4 inch. So that's nice. Hopefully these little kind of tips help you design your part. So you have all this, you got a hole. Let's go back to our original intent. We need the hole going all the way through. So I'm just going to go, instead of offset from surface, through all, check, yay. Okay. So now let's say we wanted to have something to, a way to wrap the coils around. So what we're going to do is we're going to cut a slot here, and then we're going to use our circular pattern tool. So I'm going to go again to this front plane here, and I'm going to go to my features, right? And I'm going to go here to extruded cut, and I am going to orient it so that I'm cutting a circle right here. So I'm going to check my circle, and look at this. See how the orange, the perimeter, the circumference of the circle highlights up? I can snap the center of my circle to that and just create an arbitrary size. And it's still blue, which means there's some freedom. And the freedom in this case is the diameter and the location around. Notice it can't leave the circle because I've constrained it. See that yellow coincident command? But what we gotta do is define the diameter. This will be up to you, right? So let's say, I don't know, let's go with 1/2 inch. Let's just see what that looks like. Okay, 1/2 inch, that looks good. What else? We could do, now let's say we want it vertical right on top of this line. So what I can do is, again, control click this origin, and I can control click my circle and look at my tabs pop up. Instead of coincidence, because it's going to complain if I do that, I can do vertical, and now it snaps it perfectly vertical to the origin. Great, and everything is black, can't move it. So I accept, exit, and again, it asks me the question, well, how far do you want to extrude it? Let's extrude it all the way, check. Okay, now that's only one hole that goes all the way through. Let's say we want to make 4 or 6 or 8. Okay, so what we can do is we can go here to your circular pattern. Notice under the features tab, circular pattern, okay? And what I'm going to do is come over here and go, well, what am I going to circular pattern? The features, and notice it makes a new ability to get to this design tree. So I'm going to grab this extruded cut, because that's what I want a circular pattern. And then the question is, what do you want a circular pattern? What's the axis? Well, the axis can be represented by this inner cylinder. We could create an axis, but right now this is actually good enough information for SolidWorks to know that it's circular patterning around this axis. So I click that and bang, and I have the number 6, great. I could change that to 4 if I wanted to. So if I do 4, notice it gives me the preview. If I do 3, it gives me a preview, right? So you can play with all the different things here. So let's do 6. Okay, and then I'll hit check. Excellent. Okay, let's say I go, well, I don't want this so rough here. That seems like a sharp edge. No problem. We can go over here to the fillet command and then hit fillets. And notice it makes a nice fillet. This number controls the radius. So if I want a bigger radius, I can put 0.2. Nice big radius, right? And I can click all of these, right? Okay. You could go over here and do the same thing to the backside. Why not? For fun, right? Okay, and because SolidWorks is so nice, it just calculates all the, you don't have to like go and extrude a cut all the way around. That'd be weird. This fillet tool makes it really nice. Bang, beautiful. Okay, so we have our rotor. So let's save our rotor. So save as, and we'll save this to, we'll just save it to a file on my desktop. So let's say new folder, we'll call this motor, okay? And then we'll call this guy rotor, okay? So we're gonna save rotor in motor, okay? So now let's say we wanna create a stator. So we're gonna go file, new, and we're gonna create another part. So part here. And again, we have nothing. We want to create a stator. So we go to the front plane, extrude. And now we're in the 2D part, 2D world. And we want to create like a hollow cylinder. So we can do this and we can do this. So 2 cylinders. And I can go to my smart dimension. And let's say what did we say the diameter of the other one was? I think it was like 2 or 3 inches. It doesn't matter. Let's just say it was whatever it was. We'll just put our own dimension right now. 3 inches, And let's say we can define the thickness. So no matter what the inner dimension is, we're going to have the thickness be, I don't know, 0.5 inches. Okay, and you guys can adjust all this. So let's say I'm happy with that, and I want to make this stator, I don't know, we'll do 2 inches. Okay, so that'll be our stator. Check. And I look at the stator, I'm like, okay, I probably need some mounting holes. So I can go over here again. Let's go to the edge of here. And I want to drill my holes. I can do extruded cut. I'm again in the 2D world, and maybe I'll make some circles, right? Now I could draw 4 circles, or I could draw 1 and circular pattern it to save myself some time. But I would want to locate that circle. So here's some dimensions I could put. I don't know, I want to make it a 1/4 inch circle, but I want to give it some tolerance. So I might give it 20 thousandths just to make sure I can fit it in there. I might want to smart dimension the distance, the diameter, sorry, not the diameter, but the distance away from the origin, right? So maybe 1.75, okay? And maybe I even want to specify the angle. So here's a way to specify this angle. What I can do is I can go in here and go center line, and I can do infinite length if I wanted to. So I could create 1 center line here and 1 center line through here, okay? And I go accept. And this is not something you have to do, but this might make it easier. So I can control click these 2 lines. And if I hit coincidence, they'll snap to each other. And if I rotate this line, notice that the circle rotates with my line. And I can now go to smart dimension and smart dimension that angle. And so let's say I want it to be at 45 degrees. Bang. Everything's black, everything's fully defined. Awesome. I go check. Yay. Okay. So I go through all, and here we are. We created 1 circle. And what did we do in the last one? We went to circular pattern, okay? And I can go in here and it was like, what's the dimension, the direction? Okay, we'll click the cylinder. And what are we circular patterning? Oh, I already had it selected, so it looks like the cut extrude. And let's say I just need 4 holes, right? So check. And now I have 4 holes. I could have gone and manually done each one, but the nice thing about the circular pattern, I only need to do 1. Okay. Okay, let's put some magnets in. So we can go back to the sketch and we can go, well, I want to put magnets in. So I'm going to do extruded cut again. Now I'm on the 2D, good. And I'll just draw a rectangle. So I can go in here, draw a rectangle. Maybe I have 2 magnets, but here, check this out. There's some nice things I can do with these construction or center lines. I can define a construction line right down the middle here, okay? And I can define another one right down the middle here, okay? What's nice about that? Well, watch this. I can go right click and I can say select midpoint. So I have the midpoint selected. See how it's close but not quite on the middle? I can control select and select the center line and I can say coincident. Bang, that means this is always in the middle. That's kind of cool. I could do the same thing here. I could right click this line, hit select midpoint, and then this center line here, and I could say coincident. So now this rectangle is perfectly symmetrical about the origin as I drag it. That's a beautiful thing, right? It makes it easier to make adjustments. All right, so then I can go in here and define, well, what is this distance? I don't know, 3, looks like it's 3 maybe do 3.4. Okay, and then what's this distance? Well, it's going to be whatever, you know, thickness of your magnet, maybe 0.75. I don't know, whatever you choose. Okay, and so now when I extrude this, it's going to cut this out, a rectangular hole right through my entire stator. Fantastic. Okay, so if you wanted to, you can add feet, whatever you want to do. I mean, there's so many things that you can add to this. But yeah, here is your, here's a rough stator. Okay, so now let's save this. So file, save, and we can save it back into that row. We'll call it stator, okay? And let's create one more part. Let's create an end cap. So we forgot, let's say, how big this is. Well, we can always go to evaluate, measure, and we can click here. and it says it's 4-inch. Okay, we got a 4-inch diameter, great. So I can go File, New, Part, great. And what do I need to do? I'm in the part, click a plane, Features, Extruded Base. Okay, we're getting a little faster now, Circle. Okay, and I can go here and I can make this 4 inches. Great. Now I can go here to your circle command. I want to maybe make a hole for my bearing. Let's say my bearing was a 1-inch bearing. So you could play with this tolerance, but if you put 1 inches, you might know that it's going to print it a little bit tighter. So maybe you print it exactly 1 inches, and then when it prints tighter, you're going to be able to press fit it in. But you got to be careful. If it's too tight, you might crack your 3D print, right? So just be aware of that. Okay, so put that in, and I have a little plate. Maybe I make it, I don't know, 0.1, 0.25 inches, something like that, okay? If I wanted to put a feature on it, let's say I wanted to put maybe something just to hold my brushes in. I could go click Extruded Base. Now I'm on this plane here, and I could put some rectangles, right? 1, 2, right? Now, I'm gonna be a little lazy here. I'm not gonna smart dimension everything, but I think you guys get the idea. And when I exit the sketch, look how it gives me a preview, right? Let's say a 1/4 inch, whatever dimension you want, bang. Okay, so I think you guys now have the idea of how to make parts cylindrical. We can put some fillets on it. Maybe you want to make this stronger. So instead of a fillet, you put a chamfer. Watch this chamfer. I can even select this line here, right? Boom, boom, just to make sure it's nice and strong. So there's all these fun things you can play with, and because the 3D printer just does the work, you don't have to go and machine any of this. You just, whatever you have in terms of your wonderful little brains, your imagination, you could just program it in and then have it print and hold it. Okay, so we have this. We have a stator. We have end cap. We have a stator, and we have a rotor. So again, let's save this, and we'll call this end cap. Now, the last thing I wanted to show you is how to put it all together in assembly, because there's some really nice things that an assembly will allow you to do. First of all, it'll allow you to see what it's going to look like when everything's together, but you can actually edit from the assembly, and it's going to make things a lot nicer. Okay, so we're going to go to New, Assembly. Okay, and what I'm going to do is, listen, you want to pick the first part to go in your assembly as the one that you think is not going to move. So in this case, let's say it's the stator. So I'm going to put the stator in. Okay, even though we created the stator second, we're going to put the stator in as our kind of first part. Now, you don't have to do this. I like doing this, and what this step does is it aligns the origin of my first part here with the origin of the assembly itself. So what I do is I go right click and I call float. Do you see this? And so now this thing is free to move in the 3 axes. But what I do here is I want to mate the front right top plane to the front right top plane of the assembly itself. So front and front, I'm control clicking those, and I go here, see the different tabs? I go to the assembly tab and hit mate. Bang, okay? So I go check, great. Now, while I have this kind of mate tab up, I can go, look at how I have another design tree. I can now go top and top, bang, okay? And I check. And so here I still have that mate design panel up, right and right, bang. Okay, and they ask me, do you want any more? And I go, okay, I know, I'm done. Okay, very good. So I scroll in and out, and now everything is locked. So now let's bring in File, Insert. So we can either go File, Insert, or we can go here, Insert Components, and let's go bring in, look at this, the rotor. So there's the rotor. Excellent. So we have the rotor there, and obviously the rotor's not aligned, but we can go click here and then click here by a control, and we can go to mate, right? So you can either click the features you want to mate and then hit mate, or you can have this tab up and then you can click the 2 features that you want to mate. It's either or. SolidWorks is flexible. So once I click that check, notice it will align the centers of both of these. Okay, let's say the other thing I want to do is align the edge of this face to the edge of this face. Bang. Okay, so I hit check, check, yay. And if I watch, I spin this, notice it stays constrained. It shows you the freedom of motion. Now, maybe in your assembly, you might not align this face to this face. That might not be a good idea, because if you put your end cap here, the wires wouldn't have any place to move. So maybe in your alignment, what you might do is go, okay, let me change that mate. I don't like that. Watch this. You can go all the way to the design tree and all the mates you made show up here. Also, all the mates for just the rotor show up here, and all the mates for the stator show up here. Look at the 3 mates that we made for the planes and the concentric mate and the coincident mate. Those coincident mates are here and the concentric mates are here, but they're not up here. So you have different ways to access the mates that you've made. So let's go here and edit this one. So I right click and I go edit feature. And watch what happens if I change this from a coincident mate to a distance. I can choose, let's say I want to count for, I don't know, 3/4 of an inch. Oh, wrong way. The other way, watch this flip dimension. So there's enough room to wind my coils around. So I can go check, okay, check. And in the mate, I can see, whoa, I totally did not make this stator long enough. I could go to Solidworks, Windows, Stator, and update for sure. But here's another way to do it. I go to Stator here. I go right click and I go edit part. And I can say, well, it asked me to save this. So I'm going to save this as my, yeah, sure, assembly. And I'm now, notice I'm going to be in the part, notice everything kind of grays out, in the part of the assembly. So I'm editing the part in the assembly. That's really nice. So now I can go to the drop down menu here, or the design tree, and I can go to this boss and I can go right click, edit feature, as if I was in the individual part itself. And I can change this to maybe 4.5 inches, right? Check. So, and it shows me the updated version. And what's cool is it even updates the part itself. So if I went to open up the individual part, and I'll show you, so file, so Windows, and I go to Stator, okay? Notice this, the individual part got updated. That's nice. I don't have to do this back and forth silliness. So I go back to my assembly and I go, okay, I like that, check, okay? The other great thing about the assembly is I can measure things. I can go evaluate. I can measure, for example, the distance between here and here, my gap distance, right? Look at that black line. It tells me I have a gap of 0.625 inches. That's super nice for your design, so you can design things in. You can put multiple parts in. So let's go here. We go File, let's see, oh, sorry, Insert, Component, Existing Part. Yes, Existing Part, okay? And I can now put in my end cap. So the end cap's there. And so notice it's just kind of floating around. Now let's mate this surface here with this surface. So I control selected both. I go to my assembly tab, hit mate. Okay, and we'll go, oh, that's not right. It's not supposed to be mated like this. It's supposed to be the other way around. No problem. You can go over here and you see the mate alignment. You just reverse it. Bang. So hit check. Again, I want to get the things coincident here and here. Good. And I hit check. And I could even, so let's just check this. I can even get the rotational alignments, because if I, here, watch this. I'm going to go click this and I'm going to make this, what do you call it? I'm going to right click and I'm going to make it, not hide it, but I want to change the transparency so that I can see through it. See how this has the ability to rotate in there? Okay, right? The other problem, look at this. With the assembly, you can see, oh crap, I made that too big. That's not going to work. So the assembly allows you to catch these things, right? And you can see that this is rotating. You could go in here and say, well, I don't want it to be able to rotate like this. I want to go to the top plane and make sure the top plane of the entire system, doing a control click, is mated. So I click, and I go mate. Bang, you see how it rotated? I go check, I accept that mate, and I go, oh, cannot rotate anymore. This is good. Here's the last kind of, towards the last of the features I want to show you. I could actually cut the holes here based on these holes here. And let me show you how. This is pretty, this is an advanced technique right here. So we're going to right click and we're going to go edit, not feature, edit part. So I'm now in the end cap part in the assembly. Okay. So now that I'm in the end cap part in the assembly, and here's my design tree, I can now create, so I can go here, and I want to be in features, I want to do extruded cut, and I'm going to click this face, okay? So now I'm in a sketch on this face in the end cap part in the assembly. It's like was it Inception? I'm a dream in a dream in a dream, right? I'm on a sketch on this plane in this part in the assembly. Kind of nuts. Watch this. I could go and draw a circle for these 4 circles here, or I could do this really cool thing. Watch this. See this circle? See how it lights up orange? I could click that circle, control click this circle, control click this circle, control click this circle. So I now have those circles selected. I can go to my sketch and I can go to this guy called convert entities. And if I click convert entities, wow, it just makes that sketch right here, projects it right into my sketch. So I don't have to go in and manually draw that. And the other cool thing is that these circles, as long as they don't get deleted, just move slightly, this will update. Now this can cause problems because if these circles delete, Solidworks will go, hey, where did those circles go? And you'll have to go into the sketch and just kind of delete that relationship. But for right now, this might be really nice. So I have those circles, exit sketch, and I can go, all right, let's cut it through all, which is only going to be the part. It's not going to cut it through all the assembly because I'm only in the part still. I hit check, and sure enough, I got those circles right there. That's so neat. I can escape the part, so now I'm back in the assembly, and I can also confirm if I go to the end cap that it modified the end cap. Look at that, it put the holes there. Oh my God, this is amazing, amazing. So I go back to the assembly, I go here, I can go and make that, what do you call it, not transparent anymore. I can see this rotate. I mean, this is a big part of your project. If you get to this point, that's pretty good. You can take these, you can throw them into the printer. How would I take it, throw in the printer? Well, I go here, I go to open part, right? And then what do? I go file, save as, and you want to save it as what we call an STL. So you guys see STL here. So you get STL, and then options, any options that you really need to care about. You could change the quality, so you could make fine, right? Okay. You go, okay, no problem. Hit save, boom. It cuts it up into triangles and makes a surface, and that's the file that you're going to use for Cura or Simplify 3D to chop it up and then have your 3D printer make it. Okay, I think that will get you guys really started. I do recommend going to either Autodesk Inventor or SolidWorks and actually going to help and going to the SolidWorks tutorials or the Inventor tutorials, running through that. And combined with this video, I hope that really gets you kickstarted into making parts. And what I'm also hoping is that you don't just stop at making parts just for this project. You make different parts for your own fun, right? Like, check this out. This is for my research, or just for fun. That you can go to Thingiverse and print off things. So the nice thing about knowing SolidWorks, though, is that you can make your own custom designs. Really neat stuff. Okay, have a great day, and I hope this was useful. Okay, bye.